This video will walk you through running the Breusch-Pagan test in SPSS. Unlike most of the tests we're going to run in SPSS, this isn't pre-programmed into the package, so you actually need to go through several steps or write a macro to teach SPSS to do this. So as opposed to writing a macro, I'm just going to show you the steps because that's what I'm more comfortable with doing. So we're looking here at the data set. It is called FOC Sales 6. It gives us information about the sales from 265 consecutive months of a fiber optics company. So the first thing I'm going to do is go into Analyze and then Regression, select Linear. My dependent variable is going to be sales. My independent variable is going to be months. And they're there because I just did this a second ago. And then I'm going to click Save and select the unstandardized residuals because I'm going to need them for later. Click Continue and then click OK. So it gives us our general regression output. If I scroll back to my data editor, I now see that it's given me my residuals. The first thing I need to do is create a new variable called residual squared, literally just my residuals squared. So I'm going to go into transform and then compute variable, and I'm going to call it residual squared, and that's equal to residual times residual. And the way I did that to bring that over, that residual over, I just clicked here, then clicked the over arrow in order to do that. So again, I just made this video and messed up, which is why that data is already appearing in there for you. Okay, so it goes through and it creates that new variable. And I will go back to my data editor in order to see that variable. Now I need to know a little bit about that variable. Particularly, I need to know its sum and the number of observations. Well, I have the number of observations has to be the same as the number of observations on my data set. But either way, in order to get that, I'm going to go to Analyze and Descriptive Statistics, and I'm going to do descriptives on this RS residual squared variable. Bring that over there, select options. I need the mean and the sum. Now be careful, sum is not normally checked, so make sure you check off that sum. It's going to give me some other information, but I don't necessarily need that. So I'm going to click continue and then click OK. And it gives me this information. N is 265 and RSS, which is the sum of my squared residuals, is a really large number, which if I try to read, I will read wrong. So literally write down these numbers. Write down that N of 265 and write down that number, that sum number there beginning with 455. Literally write them down on a piece of paper because we are going to need them now to calculate something that we're going to call G. So I'll go back to my data editor and I will create my new variable, compute variable, and I'm going to call this G. Okay, now G is equal to my squared residuals, come on, bring that over there, that divided by that sum, that RSS, sum of squared residuals, divided by N, the number of observations. So this is why I said literally write it down, because you need it. So 455,004,2800 divided by 265. Close that parenthesis and click OK. So now I've created my new variable G. And I can go over there and look at my G. Okay, G has been created. Now, my next step is to compute Z's. Z is used to classify an omitted variable. So Z is like, you know, something I could have used in my model, but I didn't think of it. You can also see Z referenced when you maybe have two variables that are highly correlated with one another, and there's a third variable that, you know, has the same relationship with the dependent variable but isn't correlated with one of your other independent variables. So you'll see Z, you know, that label used in there as well. So for these z's that I'm going to do, I'm going to take each of my independent variables. In this case, I only have one, which is months. But if I were doing this for longer regressions, I'd take each of my independent variables, square them, cube them, and raise them to the 4th power. So I'm going to create, in this case, 3 new independent variables. And I'm doing that because I only have one independent variable currently, months. If I had 2 independent variables right now, I would have to create 6 new z values, where, taking each independent variable and raising it to the squared, 3rd, and 4th powers. So transform, I'm going to compute now this new variable z. We're going to call this z1 on months. Now, do I have to call it z1 on months when I know that there's only, I'm only doing this for months because it's my only independent variable? No, I probably could have just called it z1. But, just for, getting used to the idea that you can do this with additional independent variables. And that's equal to months times months. Sorry. Okay, and we'll click OK. So now we have z1 months. And it goes down and it creates that new independent variable, and I'll bring up that data editor so I see that. Now I can compute my next one. It's going to be z2 months. And that's months times months times months. Months again. Okay, bring that over. Right, click OK. It created that one, and let's go back and do this for our 3rd. So transform compute variable z3 is now going to be months to the 4th power. So times, this over here, times, and bring the months back over there again. Okay, click OK. All right, now go back to my data so I can see what I'm doing. All right, so now I've created my 3 z variables. Next, I want to run a regression where my dependent variable is my g, and my independent variables are all of my previous independent variables, which in this case is just months, and all of my z's. Okay, so I'm going to go into Analyze, Regression, Linear, and now my dependent variable is my g, and my independent variable is months. I'm still going to use that. I'm going to add in now months, z1 months, which is months squared, z2 months, which is months cubed, and z3 months, which is months to the 3rd. And then I'm going to click OK. Sorry, I can't see the mouse on the video. All right. Now, to get my Breusch-Pagan statistic, if I look through here, I'm looking to see how many degrees of freedom, what sort of information I'm getting out of this. Okay, so predictors, tolerance, G. It actually eliminated one of my independent variables because if I go down here to my excluded variables, months squared was perfectly, months squared was excluded because, or months to the 3rd was excluded because it had too high of a correlation. So my degrees of freedom, if I go back up here, my degrees of freedom is actually 3 instead of 4, even though I did have 4 independent variables, because that one was automatically omitted because it had, its covariance with another independent variable was too high. So to actually calculate my Breusch-Pagan statistic now, it's n times the r squared of this regression. So the r squared of this regression is 0.276, and the number of observations, down here, where is our n? Back up to the top. Why am I not seeing my N anywhere? Okay. Oh, my N's 265. It didn't change. I just forgot what the number was. Okay, so my Breusch-Pagan statistic is 73.14. That's the actual Breusch-Pagan statistic that I am going to use. Now, I need to compare that to a chi-squares distribution with 3 degrees of freedom. So what I'm going to do for that, instead of opening up to go through and do a syntax editor, I'm just going to bring it up in Excel because I feel more comfortable entering equations in there. And the way I'm going to calculate that is chi-dist x is that 73.14 that I just calculated with 3 degrees of freedom. So my Breusch-Pagan statistic, comma, my degrees of freedom, and my degrees of freedom again is 3, not 4, because one of my independent variables was deleted because it's had, you know, too high of multicollinearity. And I'm going to come up with, yeah, that's definitely significant, basically 0. So my HO here is that my residuals are homoscedastic, meaning there is not a heteroscedasticity issue. And I am definitely rejecting HO, so that's telling me that I really, really do have a heteroscedasticity issue here in this data. And in a subsequent video, I'll show you how to fix that.